most of you know me. And I don't know if any of you have actually tried cross-compiling with dhc yet. But it seems that people are interested in doing it anyway, so I thought I'd show how we can get dhall-json to cross-compile to Raspberry Pi, and show what all the issues you might run into and what the solutions for those are, so you don't get scared away. Okay, so yeah, that's me. You can follow those Twitter handles if you want, and occasionally I write something there, mostly about cross-compiling. So let's get into it. dhall-json is this program where you can feed in dhall on the other one hand and get JSON out on the other side, and it comes with a second executable that basically can also give you YAML on the other side. So what do we need? You need the Raspberry Pi SDK and the toolchain wrappers. I have the links on my website, and I probably also put them on the meetup page, so you can look them up. You probably want to check out GHC at that revision. And you need two GHCs. You need one for your build machine and one for your target. So in this case, my build machine is a Mac, so I basically built for Mac, and the target here is the Raspberry Pi. And you also want a rather recent Cabal checkout. So let's start and say, okay, let's just unpack whatever dhall-json is and then try to build it, right? That does not really work so well. I mean, you know these Cabal errors, right? You try to build something and then it just fails, and you're like, what? Okay. That Cabal comes basically from the toolchain wrappers that just appends a bunch of arguments into the regular Cabal command. Otherwise, it would probably be half the page adding with GHC package, which HSC to HS, and all of these. Because we don't yet have a host expansion in Cabal. I have a small patch for Cabal which basically takes it basically parses the arguments that you give to Cabal and then just expands host if it finds host, but that's not really good, because if you have host somewhere in here at the configure flags, then it's just going to break. So yeah, I hope we'll have eventually a better one. So anyway, you see this basically fails because it couldn't fulfill all of those. So let's start digging in. The first one we see is if we allow newer, because we're obviously using a recent GHC, usually run into the upper bounds. And if we do this, we actually see, oh, okay, we try to find integer GMP, but the cross compilers are usually built with integer simple, so you don't have integer GMP. And that is an issue if libraries hard code integer GMP and basically say, I want to depend on that. And the library that does this here is text format. So what are we going to do? We're going to create the Cabal project file first, because then we can basically say what packages we want to include in our local build. And we start with a Cabal project file that's empty and basically just contains the dot for the local package, and then it just builds. When you then ask Cabal for new build, it will just basically build the current package. And then we basically ask Cabal to unpack text format and add it as a second package into our Cabal project file. If there are questions, just ask at any time. So how do we drop integer GMP from text format? Well, we can just try and go into the Cabal file and drop the relevant lines and see what happens, right? Interestingly, the next thing is Cabal reorders the goals, and you think it works. Obviously it doesn't, but we will get to that later. The next thing is it tries to build Kryptonite, and that one has automatically enabled integer GMP as a flag. So that's easy, right? We just disable that. Luckily we have our Cabal project file, and we can just specify for each package, you can basically give the name and then give the flag. So we say basically just disable integer GMP. I guess we could try to build it, but I haven't had success building for all platforms. So I usually just stick with integer simple because that's easier. But yes, in principle, we could try to build integer GMP. I mean, integer GMP has the issue that if you link it, you're in GPL land, so you might or might not want to use it for example. If you want to distribute on the Apple iOS App Store, then you're basically precluded from distributing anything that's GPL encumbered in any way. So let's try building it again. This is going to be a common theme, though. I've tried to switch the titles a bit. The next one is Blaze doesn't build. And why does it not build? Because it has a monoid instance. Now, where does that come from? Recent GHCs have the monoid semigroup proposed implementations, which means that you basically have semigroup, which has what used to be mappend in monoid, and monoid inherits from semigroup. So that needs to be changed. But we are lucky, there's the head hackage overlay. So you can basically just add that in. If you're lucky, someone else has already provided the patch for it, and it will just work. There were the root keys, and the 3 dots are there. It's usually like pretty long root keys, but I skipped them because otherwise the slide was unreadable. Okay, after we added that to our Cabal project file, we basically need Cabal new update, so we also get the new overlay index. And let's try to build again. Oh, next issue. Okay. Now, what happens here is same semigroup monoid proposal. Base and also Prelude are now exporting the append operator. So you're running into a lot of issues where these symbols already exist because Prelude is implicitly imported. So how do we fix that? Okay. We just hide the symbols, right? Okay, hiding that from both imports. Let's try again. Oh, what now? Oh, text format, right? There was something, right? We dropped it. So let's see, why do we actually need the GMP internals here? Maybe we can just get rid of them. And luckily we can, because it's just used for base 10 and base 16 in this case, and there's a generic one for any case, any base. So we can just drop that. Of course, you might want to actually check that the library does what you expect it to do also in these cases afterwards, right? Because that could also just break it. So you might want to run tests if you have any on them. Okay, let's go. What? Oh, no, not again. You'll see a lot of these, so you keep on patching them like this, all over the place. So, next one. Oh, what's that? Same again, right? So you keep on patching, and obviously what you basically want to do is you want to... Yeah, it's usually really simple, right? You just drop the append lines and move them up into the semigroup. And what you actually want to do is provide patches and then upload them to head hackage as a pull request so that others can also benefit from your work. Let's keep on building. Okay, same again, patching again. And it keeps on giving all the time. So you patch even more, and then we end up here. Now, what happened here? This is zlib, which uses HSC to HS to embed constant strings. But luckily you don't actually need those. And we can't... well, maybe these days we actually could, but so far HSC to HS could not use constant strings. So it basically means you have a constant string expression that you try to evaluate at compile time and then embed that into your GHC program, in your Haskell program. And because that's not supported in cross-compilation mode, we could luckily patch that lib, but it hasn't been released. So there's no release been cut. So what we do is we just use the version from GitHub and keep on going. Again, whenever you add a package to your local, you also need to add it to your Cabal project file. So what fails next? Let's see. Oh, this is also lovely. So you see, basically, it tries to build, and then it says, "Oh, a failure occurred during the configure step, and it terminated with some exit code." Like, what? What actually happens is that if you have a package that has build type custom, they usually provide a setup HS in the package. Now, if you build that with a cross compiler, Cabal goes ahead and uses the cross compiler to build this setup, and then it tries to run that setup on your build machine. Now that usually doesn't work unless you're really lucky and your build and host machine use the same operating system and the same architecture. Then you might actually be lucky and it runs. But in most cases, that's just not the case. Well, maybe you want to compile an x86 64 from Debian to Ubuntu or whatever, and you just want to use a different libc, or I don't know. I mean, there are situations where I can imagine you might want to do it, but most of the time your architecture will be different. You could probably try to use the QEMU userland, where you can basically evaluate a program for a different architecture as in user space. But in this case, we'll just change it to simple. That works mostly because a lot of packages have the build type custom to support some headhook hooks, or to support doctest as a test suite target. So from all of those packages, you can basically just safely change from custom to simple. So let's keep on building. Oh, another one. Yeah, and it's basically all in the package from Edward Kmet. They almost all use doctest as a test suite, so that's why you need to kind of patch them all. Okay, yeah, now, next lovely thing. When you build with a really recent GHC, parts of contravariant are now part of base. So if you have packages that depend on contravariant, and contravariant is in version 1.4, I think the next one is going to have that implementation guarded, so it's not going to export the duplicate modules anymore. Then you see this lovely error. So what do? We add version implementation guards, and with that we get a bit further. Now this one says this operation requires external interpreter. What is the external interpreter? Anyone use that? Okay, so GHC has the ability to run template Haskell splices, annotations, and interactive code in a separate process, and that's where you can basically use the interactive interpreter for. And usually GHC, if you build it, comes with a binary that's called iserve, and you can just point it towards that. And if you don't provide any argument to external interpreter, it just tries to launch iserve and run all the template Haskell that over iserve. Now, in our example, our build, so if your build machine and your host machine are the same, you can just communicate over system pipe. That's no problem. But if your build machine is not your host machine, then you need some kind of network to communicate over. And that's why we now have the iserve proxy and the remote iserve. So the iserve proxy is basically just a program that GHC can communicate through pipes to, and then that thing communicates over the network with the remote iserve, and it also does some file shipping. So whenever there's a library that the remote iserve needs to load, then the iserve proxy, it can basically ask the iserve proxy to send that library over, and then it can load the library. It's a bit tricky on Windows because you might not see the dependent libraries, but luckily that's rarely the case. So how do you build iserve proxy? Because GHC does not bring network as a library, you need to build it yourself. So you go into the GHC folder and then into the utils iserve proxy, and just go ahead and say, okay, cabal new build, and it will produce iserve proxy in a rather deep path someplace. And you just copy that into your path somewhere. And then you need the iserve remote as well. Building that is similarly easy, but in this case, you need to make sure that you actually use the either the cabal through the toolchain wrappers for your target, or you use cabal and provide like with GHC and then your target GHC. And you also want to provide configure option host because that's passed on to network, and network needs to be built for the proper host. And that will basically give you the the executable somewhere in the path pretty deep. And obviously, if that was Windows, it would be a .exe file. Now, how do you run this? Pretty trivial. You just copy it to your Raspberry, and then just invoke it, and it takes basically a path where it stores a temporary file. So whenever it needs to load a library, it basically asks the isurf proxy, and any file that sends is then stored somewhere under temp. And the port I use here is 5001. So now that we have the isurf proxy set up, we can basically add the following GHC options to our Cabal project file. And this launches the external interpreter and gives the program for the interpreter is this one. So I renamed it to have the same prefix as all the other cross-compiling tools. And then you basically provide the first option is the IP address of my Raspberry Pi, and the second option is the port. And with that, we can build again and run another monoid issue. So let's finally patch up dhall as well. And if you've done that, there's another one you need to patch. And after that, we're building and we're done. We get both executables. Or do they work? Because obviously we can compile whatever we want. It doesn't really matter if it doesn't work, right? So we copy the dhall to YAML file to a Raspberry Pi, and then basically execute it on the Raspberry Pi, giving it the dhall expression with a list and a nested dictionary, and looks like the proper YAML file we expect. Doing the same for dhall to JSON also yields the right result, so that seems to be okay. Note, we have not really check that text format does the right thing for base 10 and base 16. But yeah, at least we can build proper binaries so far. So the final Cabal project file would look like this, and here's like the extended root keys for the hackage overlay, and you can see all the packages we need to patch are in the first line, and we might add a flag to Cabal that allows you to override the build type. So you could say Cabal new build -- override build type and set it to simple. And then you wouldn't need to patch all the pages just to add the simple build type. The root keys are there so that Cabal can verify that this is really the right repository. That's part of the trusted update framework, I believe. Hmm? I think it's 3. I don't really know. I guess Herbert would know, but I haven't really looked why I need 3. It's just like I need this for a Cabal overlay, and it's also the same you find if you go to haskell.sg. This is basically also the same. This is the same part you see. You just copy it and paste it, and there's a similar one for the mobile hackage overlay. And the mobile hackage usually has only simple to custom to simple changes. The only issue with overlays is that they don't compose. You can't use head and another overlay and basically have them compose, because obviously you can't compose arbitrary patches on top of packages cleanly. Okay, questions?